Today we are going to learn how to derive the silicon to aluminum ratio or silica by Al ratio in geopolymers. This ratio is fundamental to understanding and designing geopolymer material for various applications. Now coming to the silica alumina ratio. What is silica alumina ratio? The silica alumina ratio is the molar ratio of silicon to aluminum atoms in the geopolymer material. It strongly influences the structure, mechanical strength, and durability of the final product. We calculate it from the chemical composition of the raw materials. Geopolymer raw materials like metakaolin, fly ash, or slag provide silica SiO2 and alumina Al2O3. To find the silica alumina ratio, we analyze their oxide content using technique such as X-ray, XRF we can say, and convert these to moles quantity. Now, as it is shown, step 1 is the chemical composition as is given. So, let's consider an example where the raw material contains 55% silicon dioxide and 30% aluminum oxide Al2O3 by weight. We'll calculate moles from these data to understand the silicon and aluminum content. Now, using the molecular weight, we convert the weight percentage into moles. For 55 gram of SiO2 with molecular weight 60.08 gram per mole, we get approximately 0.915 moles. For 30 gram of Al2O3 with molecular weight 101.96 gram per mole, we get about 0.294 moles. Coming to the conversion, we can see that moles of compounds to moles of atom conversion. Since SiO2 contain one silicon atom, we have 0.915 moles of silicon atoms. Alumina, that is Al2O3, contains two aluminum atoms, so the moles of aluminum atom equals 0.294 times 2 or 0.588 moles. Now calculate the silica alumina molar ratio by dividing the moles of silicon by moles of aluminum atoms. Here 0.915 divided by 0.588 gives approximately 1.56 our silica by alumina ratio. A silica alumina ratio of 1.56 indicates a balanced composition typical of geopolymers with good strength and network formation. Adjusting this ratio by adding silica or alumina can tailor material properties. The silica alumina ratio determines the geopolymers polymer network density, affecting its strength, porosity, and resistance to chemical attack. It's a key parameter in designing geopolymers for industrial and uh, iron ore tailing related applications. Now coming to summarize, the silica alumina ratio is derived from oxide analysis via mole calculation. It is essential for tailoring the properties of geopolymer material and optimizing their performance in real world applications.